Assalamu alaikum. Hello everyone. Before doing your paper 6 chemistry IGCSE exam for May June 2023, I think it's really helpful to solve February March 2023 paper 6 to the same code 0620. So let's get started. You know guys, in this year we have something new, which is you have already the tests for the anions and cations and also gases. So this is something new, and I think also this is really helpful. So let's see. Question 1. Long chain alkanes can be broken down into shorter chain alkanes and gaseous alkanes. They perform a long chain alkane is passed over a very hot catalyst, and the gases formed are collected over water. The apparatus used is shown in figure 1.1. Here in the figure we have long chain alkane on mineral wool here, and then here we have aluminium oxide catalyst. This is the delivery tube, water. Here is the structure A. Here is gaseous alkanes, which is produced finally. So question A, name the item of apparatus labeled A in figure 1.1. So I think guys it's easy and everyone knows this is a water bath. So the first structure is this is called the water bath. Letter B, the catalyst is small pieces of aluminium oxide. Explain why several small pieces of aluminium oxide speed up the reaction more than one large piece of aluminium oxide. I know guys, the point of surface area is one important factor affecting the reaction rate. So the more the surface area, the faster the reaction. And of course, several small pieces of aluminium oxide have more surface area. So we could say several small pieces have more surface area. So the idea here is the point of surface area. Letter C, I name the item of apparatus that can be used to heat a long chain alkane and catalyst. So I think everyone knows that the item we use in the lab is Bunsen burner. So this is Bunsen burner. Okay. Double I, add 2 hours to figure 1.1 to show where the apparatus should be heated. So we need to draw here 2 hours. So I think we need to draw the first arrow here below the basic reactant, which is long chain alkane, and the second arrow we need to put it here below the aluminium oxide catalyst. Okay. So next one here, this is letter D. The gas connected is tested using aqueous bromine. Alkenes turn aqueous bromine from orange to colorless as known. When the first few bubbles, take care guys here, from that first few bubbles of gas collected are tested, the aqueous bromine does not change color. Explain why the aqueous bromine does not change color. Actually guys, here, take care of this point. Here it said that the first few bubbles of gas. If you check here guys this, so of course you need to check all of this area within that delivery tube. So here you have also air. This is air inside. So of course the produced alkene will push air firstly. So the first few here, as it's mentioned, the first few bubbles, of course, it will be air, not the collected gas. So we need to say that the collected gas actually is the air, not the alkene. So because this is not the alkene, so it will not change the color of the bromine water. Okay. Letter E. As soon as the experiment is over and the heating is stopped, the delivery tube must be removed from the water. Explain what happens if the delivery tube is not removed from the water as soon as the heating is stopped? Actually, guys, this question is repeated so many. You know, if we don't remove this delivery tube, look at this, guys, please. So look at this. This is the delivery tube. If we don't remove it, so now we will allow water to move back here to the boiling tube. And of course, boiling tube is hot, so it will break this delivery tube. So actually, we need quickly to remove the delivery tube to prevent sucking back of water to the boiling tube. So we could say water is sucked back causing breaking for the boiling tube. Okay. Second question, student investigates the solubility of ammonium chloride in water in different temperatures. The student does 5 experiments using the following instructions. Experiment 1, fill a burette with distilled water. Run some of the water out of the burette so that the level of the water is on the burette scale. And then use the burette to add 8 centimeter cube of distilled water to a 5.25 gram sample of ammonium chloride in a boiling tube. Clamp the boiling tube at an angle as shown in figure 2.1. So here, guys, this is water, this is solid ammonium chloride, and this is clamp. So gently heat the bottom of the boiling tube while stirring the contents with a thermometer. Stop heating as soon as all the solid has dissolved. Continuously stir the solution with the thermometer while it cools. Measure the temperatures of the solution as soon as the solution becomes cloudy and a solid starts to form. Here, experiment 2, use the burette to add 0.5 centimeter cube distilled water to. So it means, guys, we need to add actually here an extra 0.5 centimeter cube distilled water to the mixture of the boiling tube from the previous experiment. Clamp the boiling tube as shown. Gently heat the bottom of the boiling tube. Stop heating as soon as the soil. I mean, guys, here it seems like the steps are repeated exactly at the first steps. Experiment 3, repeat experiment 2. So it means we need to add also another 0.5 centimeter cube. Experiment 4 also and 5 we need to repeat. So it means we started by 8. Here, guys, you should take care. We started by 8 centimeter cube of distilled water, and in every experiment, so we add 0.5 to the experiment, but remember that the sample or the mass of the sample was 5.25 gram of ammonium chloride. Now let's check what happens here. So use letter A, use the information in the description of the experiments and the thermometer diagrams to complete table 2.1. Mass of ammonium chloride. So I think here we have 5 experiments, and also, guys, we don't have any change of the mass of the ammonium chloride, so we should copy 5.25 here for everyone. So here the mass should be 5.25, and here it's written gram, so no need to write it again. So 5.25, and all 5 experiments you should fill this 5.25. Here is also 5.25, and finally in experiment 5 also we have 5.25. Okay. Second column here we have, this is total volume of water. Actually, guys, we added, if you remember, 0.5 in every experiment. So second one should be 8.5, and third one should be 9. And here, guys, take care, please don't write 9 only, so it's better to write 9.0. So keep 1 decimal place, because here also, if you check, try to imitate this. This is 8.0. So here we have 1 decimal place. So 8.5, 1 decimal place. So keep one decimal place in every one. So after adding another 0.5, so it's gonna be 9.5, and finally this is 10. 10 point, this is one decimal place to be zeros. Okay. Now let's go to the final column, temperature when a solid starts to form per degree Celsius. So I think we need to record this temperature, guys. So as you see, guys, here we have this is 75, 6, 7, 8. So I think it's clear it's 8.5 as you see. So we need to say 78.5, and also we need to write degrees Celsius because it's written here up. Second one, so here we have this is 65, 6, 7. So this is 67. And here also, guys, because 0.5 decimal, so also keep one decimal place by adding 0. Here, guys, I think it's very clear. It's 60, exact 60, one decimal also. And here we have 50, 51, 2, 3. So I think this is between 3 and 4. So I think this is 553.5. And here finally this is 45, 6, 7, 8, 9. So this is 49.0. Okay, guys? Okay, letter B, complete a suitable scale on the y-axis of figure 2.2 and plot your results from experiments 1 to 5 on figure 2.2. Draw a line of best fit through your points. So first of all, I think, guys, that is y-axis represents temperature when a solid starts to form. X-axis represents total volume of water per centimeter cube. This is the y-axis starts by 30. So I think we need to continue. So if we check the maximum, here this is 78.5. So if we continue from 30, so if we say 40, 50, 60, 70, 80, so I think this would be the best fit for this. So here we need to increase by 10, so this is 40, and then 50, 60, and then 70, and finally here we have 80. And then we need to take the values from here. So the first one was 8, again is 78.5, so 8, 78.5. So here we have, this is 70, 1, 2, 3, 4, 5, 6, 7, 8. So the first point should be here. Second one is 8.5, again is 67. So 8.5 again is 67. So 61, 2, 3, 4, 5, 6, 7. Third one is 9, again is 60. So 9 again is 60. So this is 9 and this is 60 here. So here's the point. And then the fourth one, 9.5, 53.5, 53.5. So this is 50, 1, 2, 3.5 should be here. Next one is 49, this is the last. 49. So this is 10, so 49 should be over here before 50. This is 49. And then we need actually to draw a line of a best fit through this. So actually we need to draw the line, and this line we should take care. So we need to continue the slide, as you see, to the best fit. Okay, guys. Letter C, extrapolate the line in your graph and deduce that temperature when a solid starts to form when a total volume of 10.5 centimeter cube of water is used. So actually we need to show that we need to extrapolate actually, guys. So from 10.5, we need to draw a line until we reach to the curve, as you see, and then actually we need to continue also. This is until it meets the y-axis. I'll try to relate in order to be more precise. Okay, so here we have the two lines. This is the one up. We need to show our work, as you see. And this is second line. So if we check the value here, guys, so this is 40, 1, 2, 3, 4, 5, 6, 7. So here we have, this is 47 degrees Celsius. So this is 47, okay? Later, the solubility in gram per 100 centimeter cube of water is calculated using the equation. Solubility equals mass of solid dissolved times 100 divided volume of water used. Use this equation to calculate the solubility of ammonium chloride in experiment 1. So the mass used here is 5. If you remember, it was 5.25 grams times 100. And volume of water used, if you remember, it was also 8 centimeter cube. So by doing it in calculator, so I think let's do it quickly. So it produces 65.5. Okay, this is the solubility. Next one, describe how the solubility of ammonium chloride changes at temperature H. I think, guys, everyone knows that the effect of temperature actually it increases the solubility, as you know. So we can say as the temperature increases, the solubility increases as well. Okay, increases as well. This is the effect of temperature on solubility. Letter F, in this experiment, the volume of water was measured using a burette. State with the advantage using a burette rather than a measuring cylinder to measure the volume of water. You know, guys, a burette actually it's more precise, or you could say it's more accurate, more than the measuring cylinder in doing this. So we can say because burette is more precise or accurate, so burette is more precise, or you could say accurate. Okay. Double I state the advantages of using burette rather than a volumetric pipette to measure the volume of water. You know, guys, that the volumetric pipette has only one portion of volume. So it doesn't give us a variety of volumes. But in case of burette, it does. So we can say here, burette can give variable volumes while pipette gives only one fixed volume. Okay, one fixed volume. Letter G, a total volume of 2 centimeter cube of water was added to the original 8 centimeter cube of water. Explain the disadvantages of adding the 2 centimeter cube of water in 1 centimeter cube portions rather than 0.5 centimeter cube portion. Of course, if we use 2 centimeter cube of water instead of 0.5 centimeter cube, we will get less points to draw to get the graph. And of course, this graph will not be accurate, so it's better to use 0.5. So we can say here it produces, using this 2 centimeter cube, it produces less results. So the graph will be the graph will be less accurate and not clear enough. Okay. Next one, this is H. Suggests why it would not be possible to use 6 centimeter cube of water instead of 8 centimeter cube of water in experiment 1. You know, guys, if we decrease the used volume of water from 8 to 6, it will not be enough to dissolve the ammonium chloride. So we can see the volume of 6, the volume of 6 centimeter cube is not enough to dissolve ammonium chloride. Okay, now this is question 3. A student tests two solutions, solution C and solution D. Test on solution C. Solution C is aqueous calcium nitrate. So calcium nitrate, guys, it means we have the cations of Ca2 plus, and nitrate means we have NO3 minus. Complete the expected observation. The student divides solution C into 3 portions. The student carries out a flame test on the first portion of solution C. Observation. You know, guys, flame test, you can find it here also. And this is one more advantage this year. So this is, as you see, here we have the flame test, and we said we have calcium nitrate. So if you check calcium, you're gonna find it here. So calcium gives orange red. So here we have orange red. Orange red flame. Okay. Letter B, to the second portion of solution C, the students adds aqueous sodium hydroxide. So actually we need to check this also. So here we have aqueous sodium hydroxide dropwise until it's in excess. Observation adding dropwise and then observation in excess. So if we check here, guys, so let's check also here we have calcium. As we said, the cation here is calcium. So calcium adding, if you check here the test, effect of aqueous sodium hydroxide here. So calcium gives white PBT or white precipitate and insoluble in excess. So we can write here. So first of all, we can write white precipitate form it. White precipitate form it. And in excess also doesn't dissolve in excess. We need to say does not dissolve in excess. Okay, letter C, to the product from B, the student adds a piece of aluminum foil and warms. So here, guys, we need to warm and also adding aluminum foil the mixture gently. Any gas produced is tested. So observation for the gas produced. So let's check also here. So we said we have nitrate, if you remember, calcium nitrate. So if you check here, guys, add aqueous sodium hydroxide, then aluminum foil and warm carefully. So what happens here, guys? Ammonia gas produced. You know, guys, ammonia gas has alkaline properties, so I think everyone knows it turns the damn red litmus paper into blue. So we can say damn red litmus paper turns blue. Okay. Letter D, to the third portion of solution C, the student adds about 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous silver nitrate. So observation, see guys, silver nitrate with nitric acid. So I think we use this test for halogens, chlorine, fluorine, and bromine. So because this is calcium, so actually no change. So here we have tests on solution D. Here we have, you see guys, test 1, use a glass rod to transfer 1 row of the first portion of solution D onto a piece of the universal indicator and give the universal indicator paper turned as red. It means this is acid. You know guys, this is acid because it turned as red. Test 2, to the second portion of solution D, add solid sodium carbonate. Test any gas produced so the solid sodium carbonate disappears and there is effervescence. The gas turns lime water milky. So I think everyone knows the gas turns lime water milky is carbon dioxide. Test 3, to the third portion of solution D, add about 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous silver nitrate. So here no change. Actually guys, no change means we don't have any halide, we don't have Cl minus, we don't have Br, we don't have also I minus, we don't have no halide actually. Test 4, to the fourth portion of solution D, add about 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous barium nitrate. And here guys we have white precipitate. Actually guys, barium gives white precipitate with sulfate. So it means we have actually a sulfate groups SO4 2 minus. So actually I think we can use all of this information to help us to the answers. Letter E, deduce the pH of solution D. We said it's an acid, so the pH should be less than 7, and also it's better to use a pH of very obvious acid. So you know the value of the pH, it means the stronger the acid. So I think we can see here pH is 1 to make sure this is an acid and also strong acid. Okay. Also, if you say 2 or even 3, it's okay. If identify the gas made with sodium carbonate is added to solution D. I think we think the gas here was carbon dioxide. So this is carbon dioxide gas. Letter G, identify the 2 ions in solution D. So we have mentioned here, we have sulfate, and in the first part we said this is acid. So I think everyone knows that acid means we have H plus ions. So actually this is sulfuric acid. So we have hydrogen ions, H plus, and we have sulfate ions, SO4 2 minus. So here this is actually guys sulfuric acid, H2SO4. So this is the compound. Last question, number 4, cadmium, cobalt, and vanadium are all metal. They react with dilute hydrochloric acid to form hydrogen gas. These reactions are exothermic. Plan an investigation to find the order of reactivity. So this is the basic idea. We need to find the order of reactivity of 3 metals. Your plan must make it clear how your investigation will be a fair test. So we need to take care about the fair test and how you will use your results to place the metals in order to reactivity. You are provided with powdered samples of each metal, dilute hydrochloric acid, and common laboratory evidence. Okay. Actually, guys, in this question, we need to investigate the order of the reactivity of these 3 metals, cadmium, cobalt, and vanadium, by reacting with hydrochloric acid. So actually, guys, we need to start our work, and also we need to take care about the fair conditions. So I suggest, and this is up to you, this is up to everyone, guys, but I suggest this route or this method. So we can start by adding, we could say add, for example, 1, 2, 3, or whatever grams. This is a mass. So let's say 2 grams. Again, guys, it's up to you to choose any mass, but once you choose any mass for one method, you should use the same mass for other methods. So add 2 grams of, let's start by the first one here is cadmium. So of cadmium to, also let's determine an amount of hydrochloric acid. So let's say, for example, you are also free to choose any. So let's say 20 centimeter cube, 20 centimeter cube of, let's say also the concentration 1 mole decimeter cube of aqueous HCl, okay? Aqueous HCl or hydrochloric acid. So of course we need to add them in a container. So let's say in a flask. Okay. So second step, actually, we need to measure the time taken for the reaction to be finished completely. And of course, you know, guys, how can we know that the reaction is completely done? So by stopping that bubbles of hydrogen, you know, here you said hydrogen gas is produced. So actually we need to, second step, we need to measure the time taken until all cadmium disappeared. So it means the reaction already has finished. Okay, and also bubbles will stop and everything will stop. And finally, we need to, after doing this and recording the time taken, we need actually to repeat the same experiment once with cobalt and once with vanadium. So third one, we need to say repeat the same experiment with the same conditions but by using 2 grams of cobalt with, as we said, exactly 20 centimeter cube of 1 mole decimeter cube of aqueous HCl. Okay, and then also we need once again to repeat with the third method. So we need to say repeat the experiment once again with the same conditions but by using 2 grams of vanadium with the same volume 20 centimeter cube of 1 mole decimeter cube of aqueous hydrochloric acid, AQ. Okay, So finally, guys, in conclusion, so I think everyone knows that the shortest time taken, shortest time means the most reactive method. Okay, guys, hopefully it was helpful. I put the solved PDF file in the box of description. I know my handwriting maybe not clear enough, but finally it can help somehow. Thank you so much, guys. See you.